Today I'll be showing a demonstration on how charged objects can interact with neutral objects, specifically insulators. It is most students' intuition that a positive or negatively charged object will not interact with a neutral object at all. This may come from when they first learn about charged particles, and how neutrons, which are neutral particles, do not interact electromagnetically with protons and electrons, which are positive and negative particles. However, in this demonstration, I'll show you how the intuition breaks down once you scale up the objects to be made of many different particles. Here, I have some tape, which is a great way to create charged objects. All you have to do is rip one piece from another, and the piece that ripped from the other one will have stolen some of the electrons from the other one, creating a positive and negative object. I will demonstrate this by having one strip of tape and then another strip of tape. This one I'll create a little handle on so I can hold it, as well as the other one. And I will stick them together. Okay, that's good enough. And then if I rip these pieces of tape really fast like this, it will show that they are attracted to each other, which means that this piece of tape, since it was ripped off the top, is positively charged, and this piece of tape is negatively charged. And you can see they're attracted as they would if they were particles. Now, I'll put these back together so I can reintroduce that charge too. Now, I have this water bottle, which should be neutrally charged, as it has not been in contact with anything that is charged and has no reason to be charged. Now, it is also important that it's made of plastic and it's an insulator. Now, I will rip the pieces of tape apart again to build their charge, as you can see. Now, this one, which is positive, I will bring it closer to the water bottle, and see, it's kind of hard to see, but it is indeed attracted to the water bottle, which maybe the water bottle has some slight negative charge, which is why it could be attracted to it. But now I'm going to bring this negatively charged piece of tape near the water bottle, and again, it's kind of hard to see, but it is attracted to the water bottle as well, which means that it is neither negatively nor positively charged, and it is neutral. But how can this be? How can a neutral object interact with these positive and negative particles, or these objects? I will move on to a simulation that I created to better help you understand. This is the model that I created for better explaining how negative and positively charged objects can influence or be influenced by neutrally charged objects, specifically insulating objects, by a process called inducing a dipole, which we'll go over more of what that means later. So first off, this is a representation of the surface of an insulating object. It is made up of atoms, which are made of positively charged nuclei and negatively charged orbitals. Now, despite the fact that I have the negative signs of the orbitals all to like one side, it's actually distributed among the entire shell here. So disregard that they're all on the same side. So what happens when we introduce a positively charged object near the surface of the neutrally charged insulator? Well, the negative charges, the electrons, should be pulled towards the object since the opposites attract. But the the nuclei, don't really move very much because they're very heavy. but electrons are very light. So what will happen is the electron orbitals will move slightly towards the object, which in turn makes the surface of the object slightly negatively charged, which will then attract the positively charged object. So that's why when you bring a positively charged object near an insulating or neutrally charged surface, they'll attract. Same thing or similar thing will happen when you bring a negatively charged object near. Now, the electron orbitals will be pushed away from the object because, again, negatives or similar charges um, are not attracted to each other, they repel each other. So, what will happen is the um, electrons will be pushed slightly further away from the surface, which will create a positive charge on the surface, which will again attract the negatively charged object. Now, why do we call this inducing a dipole? Well, this is a closer up representation of the atom, specifically when it has been um, like near an object um, or near a charged object. So a dipole is when you have a particular object and one side of it is negatively charged and the other side of it is positively charged, which creates an electric field running from the negative to the positive side. So an example for this atom representation we have here, this side is more negatively charged because the orbital is shifted that way. And then the right side is positively charged. So the atom is acting like a dipole. And once you have a bunch of these dipoles lined up like this, it creates a electric field that will attract whatever induced it. So you might have experienced this whenever you've like rubbed a balloon on your hair and it's stuck to the wall, or when unwrapping cellophane and it tries to stick to your hand. That's the same principle of what we did with the tape. Um, so that's an example of how you've inadvertently created dipoles just in your life. So thank you.